Okay, first of all, we are visualizing the problem and edge cases. First of all, I draw the pattern 1 3 4 7 1 2 6. Then the question is, delete the middle node of a linked list. So they are giving some example like 1 3 4 7 1 2 6. Then I saw that input here is equal to 1 3 4 7, like a tutorial types. So first of all, before writing a single code of line of code, let's understand exactly what the problem is asking. Suppose our linked list looks like this, look like this one. Then is 7. We have 7 nodes. Let's count them: 0 1 2 3 4 5 6. Notice we are using zero base indexing like this one. The middle index is simply 7 divided by 2, like 7 divided by 2, like a 3. Index 3 contains the value 7. That's the node we need to remove. That's the node we need to remove, this one, this 7. So before like this, after removing this one, it will be like this: 1 3 4. Then directly 1, then 2, then 6, like this one. So we have to remove the 7. So we are not deleting the value, we are deleting the node itself. That means changing pointers. Edge case 1, first of all, visual 5. What if there's only one node? The middle node is the only node. Deleting it leaves us with an empty list: 5 1 null. Edge case 2, visualize 8 9. Narrator, what's about two nodes? Like 2 divided by 2, 2 divided by 2 is equal to 1, is a floor. So that means we delete the second node. And this edge case catches lots of people during interviews. So I think we find out the problem, and we will be solve the problem according to the approach brute force, which is the most common factor and common topic to solve this problem. So first of all, we are count then delete. The most initiative solution is uh, actually very straightforward. We will make 2 passes through the linked list. First of all, we saw that visual impact, then pass 1, then count nodes, then total is equal to n. Then we find out middle is equal to n divided by 2, then pass 2 simply, then stop before middle, then reconnect the pointers. Yes, we should, first of all, I'm marking this, we should follow these rules. We should follow the structure or steps, you can see that. Okay, then first of all pass 1, then count nodes, total no n, middle is equal to 9 n divided by 2, then pass 2, stop before middle, reconnect the, reconnect the pointer. Then let's see, let's use our example again: 1 3 1 3 4 7 1 2 6. First pass, we count every node: 1 3 4 6. Then total becomes 7. We now commute 7 divided by 2, like 7 divided by 2 is equal to 3. Okay, now we restart from the head. Head. Instead of pointing to 7, we simply points, okay, just like that. The middle node disappear. First of all, the middle node disappear. Then we count the complexity site time is equal to n. The time complexity 0n, then first traversal plus second traversal, then still n complexity, then space 1. So now the solution is perfectly acceptable. I think we later we see the code base LeetCode problem, then submit the problem, and when we submit the problem, then we see the what is the happen between them. Then the tortoise and the hare algorithm, this is one of the most. So now we move to the LeetCode, then find out the okay. Now see that okay, we remove the comments type head or optional set. Okay, so first of all we are writing some comment. If not hit, or not hit that next, so we return none. Okay, so I think it will be the okay we slide between two shorter. Okay, if not or hit not next, we return none. Okay, we return none. Then okay, slow, we first of all we saw the slow, so is equal to hit, then first is equal to hit, then previous we fix the none, then while first and first next okay, first next, then after previous prev or is equal to slow, then slow is equal to slow next, then first is equal to first dot next dot next, then we move to two forwards, then find out previous dot next dot slow next is equal to return hit. Okay, then we run the program. Oh, I think first of all we are like spell mistake, then see it. Oh, perfect, our answer. Okay, test case 1, then we saw that some kind of test case 1 3 4 7 1 2 6, then 7 will be removed and output will be 1 3 4 1 2 6, perfect. Then second 1 2 3 4 1 2 4 3 will be removed, then 2 1 1 will be removed 2, perfect. Then we submit. Okay, great.